theorems again with secant lines. So I'm sure that you are sick of hearing about theorems and you're like, oh my goodness, when is this ever going to end? And you've probably learned way more about circles than you probably ever intended. But we got a couple more here, just two this time, not several. So just two here about with secant lines. So a secant line, if you will remember back, is a line or ray that is going to intersect the circle in exactly 2 points. So it's basically like a chord in an extension. There we go. It's an extending chord line. So let's take a look at some of these theorems here. And we're going to look at the picture and the equation that goes along with these theorems. So the product of the length of the secant segment is external segment is equal to the product of the other secant segment and its external segment from the same point outside the circle. Whew, okay, lots of words, but let's look here. So I have my circle here. A secant line is going to be a line segment that's drawn that crosses two points here and maybe even 2 points here, and it's going to come up and it's going to meet together somewhere. Okay, that's what we're talking about. And so basically, what this theorem is saying is that the product of these lengths, so from here to here, let's call this A and this B, is going to then times this is going to be equal to A times X times Y. So let's look here. So we're going to say whatever the segment for AB times BC, whatever that length is there, is going to be equal to AX times XY. Okay? So that's what we have here. Um, that's the products. That's what that means as far as the product goes. So secant, it's like a line or array that is going to cross a circle in two places and it's going to meet together outside. So when we talk about the external, that's the outside of the circle. Okay. So the second theorem that we're going to look at as far as secants go is that the measure of the angle formed by two secants intersecting at a point outside the circle is half the difference of the measures of the intersected arcs. So really, we either have this product rule or like central angles just congruent equal, and then we also have halves. So it's going to probably fall under one of those categories. All right, so let's draw our circle here. And our secants are going to meet outside of the circle. I'm going to draw them the other way, and I'm actually going to draw them to where they are going to go through the circle. So they don't have to stop at the circle either. They don't have to have an end point there. They can, they don't have to. So we have the measure of the angle formed by two secants intersecting at a point outside the circle is half the difference of the measure of the intersected arcs. What we're talking about is this angle right here. So I'm going to call this point A. Here we go, B and C. And I'm gonna label these with the same letter again. So this angle A is going to be equal to half the difference. So this time is the difference. Usually, so the last time is the sum. This time it's a difference of this arc plus this arc. Oh, excuse me, minus, not plus. I confused myself. All right, so the measure of angle A is what I'm going to start out by saying is going to be equal to half the difference of the two arcs. So really CY is bigger than BX. So I'm going to say the arc of CY minus, that's a Y, not a 4, and then the arc of BX. All right. So that's what we're talking about here, and then we're going to look at these just these two theorems this time. And so it's really nice just two, but keep these theorems handy because you're going to have to refer back to them time and time again. Okay, so in example one, it wants to find the measure of the angle BFE. So BFE is this angle right here. So this is going to be the last theorem that we just talked about. So I know that the measure of angle, I'm just going to say angle F, is going to be equal to 1/2 times this difference. So I'm going to say arc CD minus arc BE. So the measure of angle F is going to be equal to half of CD, which is 97, minus 15. And so I'm going to have half of 82. So then that's going to be 41 degrees. So the measure of angle F is going to be 41 degrees based on that last theorem that we talked about with secants, because these are secant lines that meet outside. So now we're going to find the value of x here. So this is going to be the part where we use the product, basically that product theorem that we talked about. It's very similar to the product theorem with the intersecting chords. So we know that the two segments times each other is going to be equal to the other two segments times each other. So I'm going to have, see, 7 times x. So 7 times x is going to be equal to 29 times 5. So I'm going to have 7x is equal to 145. And then I'm going to divide by 7 on each side. So x is going to be equal to 20.7. And then on example 3 here, we're going to look at the length of the arc of BC. So you're like, oh, hold up. I do not remember you talking about the length of arc. Well, I didn't. So we're going to have to do some solving here. All right. So I know that the measure of angle A right here is going to be equal to 1/2 times the difference of the intercepting arcs of that secant. So it's going to be arc DE minus the arc BC. Seems fair enough, right? So that's going to be equal to, so the measure of angle A is 32. And that's equal to 1/2 times DE, which is 145, minus the arc length of BC, which is what we don't know, that's X. Then I'm going to distribute that 1/2 to both of these here. So I'm going to say 32 is equal to 70, 72.5 minus, and I'm going to say 0.5x. So you can use half or 0.5, the same thing. So then I'll subtract 72.5 from each side. I'm going to get negative 40.5 is equal to negative 0.5x. Don't forget that negative right there. Divide by negative 0.5x on each side. And I am going, oh, not 0.5x. Ooh, just negative 0.5. I was like, whoa, why are we moving x over there? So that's going to be equal to a positive 81 equals x. That's why it's really important that you bring down that negative sign with the 0.5, because if you don't, then you might end up with a negative angle and you're thinking, I did everything wrong. Well, you didn't do everything wrong. You just forgot a negative sign. All right. So just two theorems this time with the secants. You're going to have that product rule basically that we talked about, where you're going to multiply the two segments together, and it's equal to the other product. And then you have the intersecting arcs. Okay, so the external angle, that angle outside the circle, is going to be equal to the half of the difference of the intercepted arcs on the other side. So again, keep these theorems handy so you can refer back to them back and forth when you practice with your quizzes if you need some more, or moving on to your skill check.